Welcome, everyone, and thank you for joining this session, Preparing Cognito for the Holiday Season. Don't let traffic spikes and bots ruin your holiday shopping season. My name is Kevin Shanley, and I lead go-to-market for Amazon Cognito, and I will be your guide on today's journey. This session is a level 300 course, so we assume that you already have a background in Cognito. And we're going to start this off with a brief introduction. I'll talk about traffic spikes and important defensive strategies to level out your traffic and handle load gracefully. Then we'll go into one of the most asked about topics, defense against bots. I'll demo how to set up the web application firewall, or WAF, for bot protection. We're going to show how to test your changes and how to protect your site with advanced security features, and finish up with a call to action. Okay, so why are we here and what do we hope to accomplish? Well, as we enter the holiday season, large-scale customer events like Black Friday and Cyber Monday can strike fear into the heart of any IT team. The day after Thanksgiving marks the beginning of the Christmas shopping season and the time of the year when retailers pivot from red ink, or operating at a loss, over to black ink and operating at a profit. It is critically important for businesses to be online and provide delightful customer experiences. But it is just as important that we not only prepare for legitimate traffic, but guard against bots and distributed denial of service attacks during this shopping season. In this session, we'll talk about handling that peak usage, cover the central role that Cognito plays in system performance, and provide both strategic and tactical advice on how to scale your system effectively to meet customer demands during peak traffic periods. So we're going to start off with defense against traffic spikes. Here are some questions to ask yourself, and really ask, do you know these answers about your own site? Things like, how much traffic can your site handle today? Logins per second, concurrent sessions, transactions per second. What's the normal traffic for your site? How many Cognito API calls do you use during a single login? What are your Cognito quotas? Have you ever hit a quota limit? Do you even know what a quota is within AWS? Do you know where to find quotas and your utilization and how it marks against that? And maybe most importantly, if you ran an email campaign on Black Friday, could your entire user base log in within a 24-hour period? So you're probably thinking, well, where do I start? Well, let's go back a little bit. And even though I'm not going to go over overall Amazon Cognito, I want to talk a little bit about the architecture here and where things like quotas and site limits come into play. So let's imagine we're making our own mobile application with the login screen over there on the left, and we're going to access some APIs and microservices. We're going to also access some Amazon resources in the green box on the bottom, like say an S3 bucket or Lambdas. And with this, we're going to use Cognito for user registration, sign in, and sign up. So we can add this functionality. Each of these operations has a quota. Sign up has a much smaller quota than sign in because it entails database rights. So if you wanted to roll out a marketing campaign to potential customers that are not already registered in your site, then this will be a very important limit to know, because you might be surprised at some of the limit sizes. But you don't have to log in locally to Cognito. You can actually use it as a federation hub and log in externally via Google, Amazon, Apple, Facebook, even a workforce provider. So this is going to give you the capability to go in and federate over externally. Those federation limits also have different quotas associated with them. So you need to be aware of those as well if you're using that type. So once you log in, we're now going to go and generate an OAuth token and go and access an API. Once again, different quotas are associated with that. Maybe your API needs to call other types of services, like it's going to use an OAuth client credential call. Once again, quotas can come into play. They could be different values than you expect. And finally, we'll go and access one of those Amazon S3 buckets or DynamoDB. For this, you're going to generate temporary credentials, use that credentials broker near the bottom. And once again, identity pools, that credential broker, it's going to use yet different quotas for that. So depending on what types of services you're using, what you're doing with your site, a lot of different limitations on a shared service can come into this. And as you can see, this is a complicated subject that is based on your application architecture, and it will directly affect your system throughput. So where do we start? Well, most folks would come here to Amazon CloudWatch. Not a bad place to start. It does have a lot of metrics. It can generate call count, throttle count metrics for Cognito. And you can use these call counts to track actually the number of customer calls related to a given category, sign-ups, sign-ins, token refreshes, and so forth. You can even use the sum metric to put together some of these metrics to get even more detailed information. But while these are great metrics, it's not necessarily the best place to go to track against your quotas. Since October 2020, Cognito has had an integration with Amazon Service Quotas. This is a dedicated console for viewing service usage. It cross-references that service utilization data against service limits, and even allows you to tools to set up alarms and request quota increases. But before we jump into the console, let's talk a little bit about quotas. So what are quotas? Well, these are the hard and soft limits that cloud providers use to enforce on a shared service. And this is to ensure availability across its customer base. Any given AWS service will have quotas, requests per second, storage limits, network limits, and others. Some quotas are real hard limits. The service will not let you scale beyond that level. But some quotas are actually soft limits. And when you hit a soft limit, well, it kind of feels the same way as hitting a hard limit. But you can request increases depending on things like how many monthly active users you have and how much utilization you're seeing. The trick here, you need to know your quotas. And we're going to cover this particular point in the next section. And we're going to also talk about how to iterate and improve on quota usage. You can even automate soft quota expansion. So beyond this, Cognito publishes extensive documentation on service quotas. On the top left of this screenshot, you'll see the service category here, like user authentications, user creations, and each of these categories, or I should say, quotas are enforced across an entire category. And what does that mean? It means that if you have a quota of 120 requests per second for user authentication, then that means you'll get 120 across the entire section, and they are additive. So for an example, on the user creation side, we have a quota of 50. And what this means is you can have 50 signups or 50 confirmed signups or 25 of each. So it is within a certain category that those quotas take effect. There is one notable exception. We'll cover that a little bit later with this. But let's go ahead and move forward. So here's a screenshot from the Service Quotas console. From this console, I can see all the information that I need about my available Cognito capacity in different categories. For example, this screen shows me my user creation quota. Similar data is available for other categories as well, like user authentication and user read. I can request a quota increase right from this console. And you might want to take note over on the left-hand side of the quota code. If you're going to call for service increases from an API or command line interface, you'll actually need to use that value as a part of your API call. And I can see all the data I need here. It shows me applied quota to the category, my usage against this quota. And I see actually in this diagram, my usage in this category is for the most part below 50%, but I had a few spikes that reached above 80. So, these are types of things that I'd want to know about, especially when we're coming into a peak day. So I can also create alarms to be triggered when the utilization is above a certain threshold. And I can create multiple alarms for, say, when the utilization is at 70% and then 80% and so on. These alarms can take simple actions like notifying somebody, or it could take an automated action like raising a support ticket, or even automating a call to increase your quota limit. Okay. I wanted to show some load tests and actually relate the importance of it with testing. So I ran actually a simple load test against this user pool to trigger an alarm that I had just created. I'll actually show how to create the load test that I used for this a little bit later. But I just really bombarded this thing with traffic. And you see my spikes are going way up. I just blew through the default quota in place, and I hit 139% utilization. I was just trying to test if my alarm was working correctly. And it wasn't. No alarm was going. So even though I was getting close to 60% error rates on these calls, no alarm was going. So even though I'd set up the alarm, set it up with defaults, it actually wasn't working correctly. So I modified my load test. And this is actually interesting in a couple of ways. This time, when I encountered an error, so when I'm doing a load test and I'm making a request for the login, and when it fails, instead of just failing and trying again as fast as it can, it would fail, and then I wait a random amount of time, 100, 500 milliseconds, 2 seconds, and then I would try again. And doing this allowed me to level out the traffic and hit 100% success rate with a 90% utilization threshold. And then my alarm activated. But it took 10 minutes, which is not what I was after. And this was my problem. I needed to generate over an 80% service quota utilization to activate this alarm. I left the default values in place, which uses a 1-minute period and a 10 out of 10 data points in a row, meaning I actually had to be above this threshold in a sustained manner for 10 full minutes. And so this is why alarm testing is incredibly important. You'll never know if these things are working until you actually go through and test them. One more lesson from this exercise, when I flooded the site with traffic, I was hitting close to a 60% error rate. This is something that your customers would see as well during this time. But once I was able to level out the traffic just by adding in a short random timer and wait cycle, I was able to handle 100% of the load and actually with a great response times as well overall. So I'd mentioned before that there was something of an exception for service quotas and categories. And that's what this exception is right here. And it's related to user authentications. So when you go to initiate an authentication, you're limited by potentially that default quota or higher quotas if you have higher monthly active users. However, the matching operation to initiating auth, which is responding to a challenge, and let's say that I go to authenticate and I have a 2-factor, one-time password that I need to enter in, and you could have multiple failed responses to this. So we actually offer you to triple the quota on those response to challenges. This allows you to actually predict a little bit more easily. So what this means is this is going to allow you to respond to failure rates in a much more deterministic manner. With a 120 requests per second, you can actually count on processing that many logins through and not some function of having a bunch of failed logins related to it. So it's just a little footnote to keep in mind. Okay, so talked a lot about service quotas and measuring these things out, doing utilization. Let's consider an anti-pattern and its effect on service quotas. So in this diagram, this organization has a post-authentication trigger. It's going to read user groups from an external user store, and then it's going to call a Cognito API to update the groups that a user has assigned. Now, this is a super useful construct. We are able to sync data for only those active users for the month. That's going to reduce your monthly active user cost because we're not going to be replicating changes in the background on a regular basis. We're also ensured that the latest data will be added to that user's account in the Cognito user pool. So what's the problem? And the problem is service quotas. User authentication and read quotas are amongst the highest quotas in Cognito and can be adjusted to really some of the highest in the industry. However, quotas for a write, an add, update, delete operation are substantially lower. If you attach operations with a lower quota, with operations that have a higher quota, that lower quota will kick in and effectively limit your operations. So after 25 requests per second, that's where your logins are going to stop. You're going to start throwing errors. You're going to start throwing 403s. You're going to start throwing quota exceptions. So, what is it actually? How do we fix this solution? Or how do we fix this problem? That user update quota is also non-adjustable. So we need to think of other alternative ways of going after this. And there can be a number of great ways of doing this. If the attribute's not changed, don't update it. Read, compare. If unchanged, keep moving. When you need to have write operations during login, maybe consider writing to Dynamo database or some other resource that's not your user pool, something that can force through higher levels of writes. You can also consider things like offline or asynchronous updates to a user pool. If something has to trigger during a login, maybe do it as a part of a pre-authentication trigger, set up an asynchronous queue, and then over the course of that login, you'll actually get a chance to level out the traffic and get those updates in. You can potentially also implement just what I did in that load balancing or that load test strategy, a randomized retry strategy. By combining a lot of these different strategies or tactics, you can substantially increase the login throughput. Okay, so we talked about that anti-pattern, and you're going to find bottlenecks in your own system, even on your own dedicated hardware. And you'll see that even though we like to think these things are incredibly scalable and can go on forever and ever, you're going to hit hard limits within your own infrastructure. Databases, caches, they all have write limitations. Global locks will limit your concurrent writes. Some databases like DocumentDB, that's going to operate in a primary replica mode. And it's going to take time to replicate that data, and you're also limited to a single writable node. The takeaway is you need to optimize writes, whether it is a shared service or not. Now, another consideration is that elastic systems need time to scale. Serverless Lambdas can scale really quickly with no intervention. They just do it. It's automagic. However, EC2 instances, Elastic Container instances, can take a lot longer, especially in the case of an EC2, where you need to boot up an entire operating system, uplift the service, pre-fill caches, make all these database connections. By the time you've called this thing during a spike, 10 minutes may have passed, 20 minutes may have passed before that service is actually being functional. And the worst part of it is, if you're having spikes, like really thin spikes, you might start firing up these services and actually make things even worse because the system's not usable, and at the same time, it's taking up database connections. It's taking up additional resources, so it's actually making your spike a bit worse. So during the holiday season, consider pre-warming extra capacity for your application. It's a small amount of additional cost and can really buy you a lot of benefits. So through this, considered a number of technical strategies to level out traffic to the site, but it doesn't have to all be technical. If you have a 10 million user base, then don't send out 10 million emails at 8 a.m. on Black Friday. Use a phased migration approach, or I should say just a phased approach, to attract customers to your site. Send these out over time. Likewise, you can drive early access to your site to spread out traffic. Maybe encourage users to self-register in your site before Black Friday so that they can get access to exclusive offers. This is going to allow you to spread out those database rights or those self-registration processes. So I also gave the example of using a retry strategy executed at the load balancer level. However, this strategy can work even better when executed in code. If a call fails due to a quota restriction, wait a random amount of time, 100 milliseconds, 500 milliseconds, 2 seconds. Just be sure not to be too aggressive on the retries. If you try to aggressively retry, you can actually cause retry spikes and cause your own outage. So just be a little bit careful with that. But it is super handy for leveling out your traffic. Likewise, mentioned it right at the beginning, know your quotas and set up auto scaling. Show how to access the service console, how to identify these API calls that could be running hot. Go through all of them, look at the rate of APIs under the service quota screen, and you'll be able to set all those things up. Likewise, pre-warm your servers that you expect to be hot going under load. The small cost of carrying overcapacity will pay off with a stable site. Understanding your flows and traffic patterns. If the user creation API is overloaded, just remember, this only affects user creation and not logins. So the vast majority of your customers are actually not being affected by a given spike. be aware of what your different traffic flows and patterns are, and don't necessarily take over aggressive actions. You don't need to necessarily reboot all the systems because people can't register when most of your customers are actually logging in and able to make purchases. And similarly, you want to continue to iterate on efficiency. So AWS SAs actually helped a customer take their utilization from 30% down to 3%, just by removing a couple of extraneous get user and verify token calls. Reach out to AWS. We can help get you these better efficiencies, and look out. We've gone through this many times before. And finally, if all else fails and there's simply too much load for your site, then consider implementing a waiting room for overcapacity. It's much better to have customers wait a little bit rather than let too many in and create a poor customer experience, or simply throw error messages. What do you do when you see an error message when you try and log in? You try and log in again and faster. You're just going to start really to create your own spikes. Waiting rooms are a great way to manage that type of traffic. Our SAs have implemented this stuff in the past and can help you. Okay, so now we're moving on to defense against bots and attackers. What are bots? Well, bots are not necessarily bad. While some bots, such as search engine crawlers, are good, bad bots are built to carry out malicious attacks at scale. The good bots are primarily things like those search engine crawlers, social network bots, aggregators, monitoring bots. These bots will obey the website owner's rules as specified in the robot.txt. Now, bad bots, well, they're built to perform various malicious activities. And estimates vary. Forrester estimates that at least a quarter of all internet traffic is generated from bad bots. The graph here from Barracuda estimates that almost 40% of all internet traffic is generated by bad bots. And they range from basic scrapers that try and get some data off an application and could be easily blocked, to advanced persistent bots that behave almost like human beings and look to evade detection as much as possible. Now, bad bots support a wide range of activities, from spin fraud and bots as a service to distributed denial of service, or DDoS attacks. Now, before I continue, some of you are probably wondering, what is spin fraud? Well, spin fraud happens when bots log into music websites with compromised credentials and then stream a song over and over and keep liking it to make it move up in the rankings. Bad bots have become really a regular nuisance that we almost don't even know goes on. As a layperson, did anyone try and buy a graphics card during COVID and then maybe come up dry? Because when the site would come online and offer a card for sale, scalper bots barraged all the retailers and got all the available cards? Yeah, bad bots are kind of a bummer. They make up a significant part of website traffic, and detecting and blocking them is of critical importance to your business. So, in summary, why do we care about them? Well, if bad bots are a regular nuisance, then it's factored in the equation, but not necessarily, because bot attacks are a scale vector. Bot traffic competes with your real traffic for resources, and this is a big problem during resource peaks. They will attempt to brute force your login page with compromised accounts. They'll scan your systems for vulnerabilities. They can launch full-on DDoS attacks during your peak shopping season. And it's incredibly easy to do as well. Fake accounts, on the other hand, as well, they cost you money. Preventing and removing accounts can save you big dollars. You're paying, not just for monthly active users, but you're paying for the CPU cycles and storage on serverless like EC2. You could be paying for network traffic that bots are generating. Your real user traffic is also obfuscated by bots. They make it harder to see what your customers are actually doing and help them out. And this is why a bot defense is one of the most asked about and requested features. So in August 2022, Amazon added native support for the AWS Web Application Firewall, or WAF. The WAF protects applications from common web exploits and malicious bots that could affect application availability, compromise your security, or just consume excessive resources. The AWS WAF gives you control over which traffic to allow or block by defining customizable web security rules. It was previously possible to provide a WAF protection with Cognito, but that actually entailed using an additional proxy layer with some other workarounds. In contrast, this is a first-class integration in both the WAF and Cognito consoles. So, questions to ask yourself. What WAF rules should I implement? What attacks can I protect against? Are some of my URLs in my application really susceptible to a denial of service? What rates do I need to apply to this for rate limiting rules? What is my normal rate of traffic? If I had a rule, could I actually break my application? And ultimately, how do I effectively keep attackers out, but also keep the door wide open to my customers? So let's talk a little bit about how it works. Well, step one, we're going to create a web access control list, or web ACL, inside the WAF. Now, this web ACL could be comprised of many rules that control bot access. They could check the request IP against Amazon's threats intelligence database. And this is useful if you'd like to block sources associated with bots or other threats. You can block requests coming from an obfuscated source, such as anonymous IPs or proxies. You can block request patterns that are known to be invalid and are associated with exploitation or discovery of vulnerabilities. You can even geofence an application to prevent access from certain countries. You can set up rate limiting to prevent denial of service attacks. There is a wide range of rules available right out of the box from AWS market security partners as well. So once we actually create that web ACL, Cognito user pool is going to fire up and pull it in and start using the WAF for incoming requests from clients. Now, some of those requests could be coming in from different clients, including the hosted UI and federation flows. They'll be coming from client web and mobile applications, even machine-to-machine authentications using the client credential flow. It is also possible to write more sophisticated rules that only apply to certain application clients or API calls within Cognito. And you can do this because when you're calling an API within Cognito, this becomes available within the header data. You can use it to constrain rules. When Cognito is then receiving this traffic, it'll then send sanitized traffic over to the AWS WAF for inspection. The WAF then runs these requests against a web ACL that is associated with the user pool, and it'll make a decision. If the decision is to allow the request, then Cognito will continue processing. Otherwise, the WAF will dictate the response to the client. And this could be, we need to block the request, or send a customer response. Or in some cases where Cognito actually controls the user interface, like in some OAuth 2 flows, sign up and sign in with a hosted UI, it'll send you a CAPTCHA to check to see if you're actually human. And a couple of notes to cover before I move on. Once you assign a web ACL to a Cognito user pool, it might take a few minutes to take effect, and your mileage may vary on this. Sometimes I assign a rule and it's in like almost instantaneously. Sometimes you need to wait a few minutes. So just an FYI when you start to test with this. You can also only assign one web ACL to a single user pool. Now this web ACL may be comprised of many managed or custom rules, but the standard 1,500 capacity unit limit is enforced. And those capacity units are used to limit the processing overhead on requests. Final note, be sure to test the limits of your rules and learn the system behavior. For example, when I run a load test against a rate limit rule, I can see that it tries to show me CAPTCHA to answer and check to see if I'm human. However, if I try and run that very same load test, but with thousands and thousands more concurrent requests, well, the system quickly realizes that this is a malicious attack, and it sends me different messages. It doesn't try and show me a CAPTCHA. It just sends me 403 forbiddens. It locks me out. So just be aware, test around, see what this is going to do from the traffic and client perspective. Okay, so in this next demo, I'm actually going to show you the WAF console, how to create rules that are assigned to your user pool and protect against bots. We're going to keep out attackers, prevent a DDoS attack, and limit the attack surface area of your Cognito UI screens. So here we're beginning at the Cognito console. You're going to click on the user pools link to show the list of pools, and we're going to add a WAF rule. And so this is actually, once you're actually in the console, you're going to click on the user pool properties, and we see that our WAF rule is currently inactive. Well, let's go ahead and click the edit button and change that. So here we can activate that, and then you can actually assign a current WebAC rule that exists, but that wouldn't be any fun. So let's go ahead and create ours from scratch. Okay. So you'll see in the upper left-hand, this is actually coming into the AWS WAF console. So we're going to call this our demo Cognito rule. And here you see right away, Cognito user pools. It's a native resource right within the WAF. And so we're going to go into this console and add our specific user pool to this WebACL. You can actually choose more than one at this point. But for this purpose, just do the one. Okay, and now for the good stuff. We're actually going to add some managed rules here. As we scroll down through this, we see the first one up here is account takeover protection, not available for Cognito. Not a problem. This is actually available right out of the box using the Cognito advanced security features. Next up, we have a rule right for bot control. Click this, and that'll actually save you from a majority of bot attacks. It's a great, simple rule just to be able to add in and fix that. Now, as we scroll through this list of different rules, we see, hey, there's an Amazon IP reputation list. We can see, rules that are associated with malicious traffic, anonymous IP list where somebody's trying to protect their origin. We also see things like known bad endpoints, and the inputs. Here we're checking to see if an attacker is sending in like specifically bad traffic that's meant to probe your endpoints. These are all great to add into your Cognito user pool. Depending on if you need a anonymous proxy or not, that's often governed by the type of business you do. So let's go ahead and move on. Here we can actually click next to a lot of these screens. You can set your rule priority, which rules you want to have activate first. You generally want to have your most effective rules and most efficient rules activate right at the top. And we can go ahead and create that WebACL. And success, it's now created. And actually, if we go back to the Cognito UI at this point, we'll see that not only was that rule created, but it's actually assigned already with this console as well and set active. And as I mentioned, may take a few minutes for it to actually take effect, but then you'll be ready to rock and roll. Okay. So moving on, I've showed now some of the out-of-the-box rules offered by Amazon, and you can browse other parts of the marketplace, but you can also create your own custom rules. If, for example, you wanted to apply some geofencing, then you can just add a custom rule based on matching a country. In this particular example, we're blocking access from OFAC, or the Office of Foreign Assets Control countries. These are countries like Russia, North Korea, and depending on your business, you may be required by law to prevent access from these nations by the U.S. government. In this particular example, added a custom 403 forbidden response, so you can actually change how these rules will appear to your end users. And likewise, in the rule configuration, I really just added a simple list of countries. However, you're not limited to that. You can actually add and or not statements to create a highly customized rule. And a quick note about IPs on the bottom here. Unless all your traffic is going through a proxy, only use the source IP unless the application is behind a proxy. In that case, you should sanitize the X-forwarded for headers to ensure that the client is not able to forge the request source. Similarly, you can create rate limiting rules to limit traffic coming from a single IP. Be sure to vet these requests against your CloudWatch rules, your CloudWatch logs. Some countries deploy proxies for all their citizen internet traffic and can have the effect of having many calls coming from one IP or a block of IPs. So just make sure you're testing that out. And you can tie together rate limiting rules with other logic if the standard rate limit casts maybe too big a net. So you can create any level of complexity of these rules to meet the requirements you need. Lastly, as you start your journey using the WAF, I've talked about how you can use the WAF with Cognito. But I would strongly suggest reading this blog. The AWS Shield Response Team, they help customers who are actively under a DDoS attack to implement rules on the fly and help resolve the attack. Now, they consulted directly with the article, and it has some great advice on how to measure your site traffic for the appropriate rate-based rule settings. The Shield Response Team also found that most customers could have actually avoided a DDoS attack if they'd simply deployed the most basic rate-based blanket rules. So it's a great way to hit the low-hanging fruit, prevent easy attacks on your site. So I'm not covering this content in this presentation because it goes beyond Cognito, but scan the QR code to learn more. Okay, well, we've learned about bots. We learned about how to make rules for the WAF. Now, how do we test that your infrastructure is ready for prime time? And a couple of considerations before you get started. Load testing costs money. It's processing cycles. It's sending SMSs. It's cross-network, cross-region network traffic. Those costs can add up over an extended stress testing. And likewise, testing a production component and on alarms requires coordination. You may have production dependencies on your load tests, so you really need to be careful about just running the stuff in a production environment. It can impact your existing traffic. So be sure to get permission, funding, and a testing window for doing this in a higher level environment. Next up, you need to load test your limits. You need to load test triggering the elastic scaling and understand the behavior of your system. If you accidentally trigger 10 new containers that all create database connection pools, then do you have enough database connections available in the database? It may not work as you expect. You may run into all sorts of things you didn't think about. You need to test. And as you test, check the logs and understand what messages are normal and what messages are like preceding a failure. Likewise, you need to test to failure. Really take your site down. Know what your app can do, know what your site can do, and what it looks like when it fails and what it looks like as it's starting to fail. And just know what you're testing for. Outages, failovers, scaling time during a spike, response time during loads, your limits and quotas. And finally, please try it on a lower level environment first. Please don't take the load testing skills that I'm about to give you and point it at a production environment without approvals and coordination. Now, with that said, in this next demo, I'll actually show you how to create a load test from scratch with free tools and generate 1 million logins in a matter of minutes. Seriously, I don't even speed up the video. You can do all this in under 3 minutes. So here, we're starting with Apache JMeter. This is a free load testing tool, and we have a blank test plan. To start off with, we need to create a thread test group. So we're actually going to create this login thread group. This is what's going to allow us to make concurrent requests. After that, we just need to add an HTTP request. And for this request, we're going to just do a direct post right to the username password login API. So for this, I need to put in the server name and the protocol to be able to access it. I'll just paste that in. Now we're going to do a post right to the base path. And we're going to send in a raw JSON form for this. So when I paste this in here, I'll make a little note. You're just going to send in the auth flow we're calling, the client ID of the application we're hitting, and a username and password. And the rest is just default. There's one more component to add to make this test work, and that's we're going to add a header manager. And we're just going to set 2 headers. One header is going to tell us, it's going to tell Amazon what API endpoint we're hitting, the initiate auth. And the other is telling the endpoint, hey, we're sending JSON-based data. So with that, we actually have a working test already. Now, we still want to add a couple other components because I want to be able to see what the test results are. And so we add some listeners. We're going to do a result tree listener and a summary result listener. And this will show us what actually happens from our test. So we'll just do a simple test request to begin. And it's already working. We have the green check mark. If we look at the response data, we're generating access tokens. That's exactly what we wanted to do. We're not load testing yet, so let's go back to the thread group and maybe have 10 concurrent users. Let's just start to scale this thing up, and 10 loops. That's going to generate 100 access tokens. And within a couple seconds, as that test scales up and stops, I think it takes 3 or 4 seconds, we now have 100 access tokens. We've logged in 100 times. And you can imagine all I need to do is add a couple of extra zeros on those clients, on those loops, and we can generate millions and millions of sessions in a very short time. It's super powerful. So likewise, to do this, I actually turned off the WAF. Let's go back into the console. We'll assign back that web ACL that we created in the previous demo, and we're going to try and run the very same load test. Okay, so now we're going to rerun, gave it a chance to work, and now we're getting back different messages. Forbidden, request not allowed due to WAF block. So here you've seen in really just seconds how easy it is to throw load at a site. And if it's easy for any of us, it's easy for an attacker. If someone wanted to come after and attack your site, it is trivial to do. And with just likewise a few clicks on the WAF, you can enable this and prevent these script kiddie type attacks against your site. Okay, so the last section we're going to cover today is Cognito Advanced Security Features. The Cognito Advanced Security Features, or ASF, are they're comprised of 3 main features: compromised credentials check, adaptive authentication, and event logging. These features are available for the local user pools only, not for federated users. So some of the caveats and disclaimers below. And there is an additional cost per monthly active user to use these features. So what do they do? Compromised credentials check. This is going after credential stuffing attacks. Credential stuffing are automated attacks on your login that attempt to use passwords that have been compromised and released on the dark web. Compromised credentials are a major attack vector, and it's a major attack vector that's also used by bots. Username and password combinations are checked against compromised credentials database during the sign up, the sign in, and change password flows. So all those flows, we're looking to see if users are using credentials that have been compromised on the dark web. And I'll say all those flows except for the secure remote password protocol, because we never actually see the password on the server side. The compromised credential database is managed, so you can't actually import your own data or modify it by customers. Compromised credential checks for compromised passwords on the dark web, but it actually also checks against all the weak or common passwords. And when those compromised credentials are detected, the flow throws an error and prevents the use of these credentials. So it'll essentially set a password reset required exception. Now, adaptive authentication allows a method of logging in with less friction if it attempts the login request is deemed low risk. This gives you the option to selectively challenge users with MFA or block the attempt if the sign-in is flagged as risk. Optionally, you can notify users of the risk and collect feedback, valid or invalid risk assessment. The recorded feedback is actually factored in for future risk calculations. So for example, if I switch countries and I log in and I get prompted for stronger authentication and I authorize that as approved, then the system knows that that I can be in another country as well. And as I make other requests from that new country, I won't be prompted again. Event risk is determined based on multiple factors, like event feedback, sufficient event history, context attributes, and previous successful sign-ins. And one final note, MFA does not need to be enabled for the user, but a phone number is needed. Finally, event logging. When the ASF is enabled, all sign-in, sign-up, verification, and password change events are logged and kept for 2 years. Event logging includes the risk level and other attributes like location, source IP, user agent, and events are not streamed outside of Cognito, but can be accessed using APIs. So you can build a custom solution to stream this data out. And the aggregate risk metrics are also published in CloudWatch. So finally, a call to action. At the beginning of this webinar, I provided guidance on how to track utilization against your quotas and set auto quota increase alarms and handle traffic spikes. You can enable the WAF for your user pools and applications, and this is one of the most powerful mechanisms to prevent unnecessary load and costs associated with the bots and attackers. One more word of caution: do not just turn on the WAF and think you're done. The WAF is extremely effective, but it can also break your application. When I used to run development teams in a previous role, if we found a bug in the app, one of the first things we did was to try and reproduce the error without the WAF. Be sure to test. And you need to stress test the system. Figure out what's going on to break your application, and then set rate limit rules to ensure that you stay in the green. Don't delay planning for when you have a spike. You need to understand your traffic expectations and set up realistic limits. Providing a reliable, consistent site for the vast majority of customers is better than letting everyone in the front door and slowing your site down to a crawl. And optimize your application. I mentioned that example of bringing in the AWS services team to help, and we helped the customer take their utilization from 30% down to 3% just by removing a couple of calls and simplifying some of their flows. Investments in optimizations pay off dividends over time in real monthly costs, but also with improved transaction speeds. You actually get a better customer experience with this. And then finally, not on the slide, but after the holiday, do a postmortem. See what worked, see what didn't, iterate and optimize the parts that didn't go as planned. And before I go, I just want to point out some other fantastic resources that are available to help you on your journey. So actually at Identiverse earlier this year, representatives from the UK National Health Service came over and presented on lessons learned as they scaled Cognito during COVID. They had to scale from 20 million logins to 800 million logins. It is an epic presentation, highly recommended. And at that same conference, Mahmoud Matuk presented a session on building CIAM applications on Cognito in under an hour. If you're more at the starting part of your journey with Cognito and you want to learn more, you want to learn how to create an app, he shows you in under an hour how to get up and running. This third QR code goes right to the service quotas page. It has all the documentation about quotas that are applied to Cognito. And finally, as I mentioned, Cognito is the front door to your application and an important component to secure. However, it's not the only thing to protect. Check out this paper on measuring your application and applying effective WAF rules. It comes with guidance from the AWS Shield response team and how they've had to respond to massive attacks in real time. And with that, thank you for attending. I hope this presentation has been useful. Please leave feedback about the webinar and let us know about other topics you may be interested in. Would you like to see a full webinar just on load testing or on using Lambdas with Cognito? Let us know in the comments. Thank you.